Alrighty guys, today we're starting something called limits. That's a new word for you, outside of using it in terms of like the speed limit. And you're going to get, it's called a lab. Now don't get excited, it's not like we're going to have on science, lab coats and safety glasses, but it's a little discovery lesson on discovering what a limit is. Let me just read you the definition of a limit. And you can kind of see how this could easily get pretty confusing until you kind of work through it. It says, the definition of a limit. This came from a textbook. I don't even know what brand this is. I have no idea. Yeah, I don't have any idea. Anyway, it says, if f of x, so y, becomes arbitrarily close to a unique number L as x approaches c from either side, then the limit of f of x as x approaches c is L. Sounds a little tricky, but you end up writing it like this little fella right here. You don't need to write anything down yet, you're just listening. This is kind of how we're going to write it. Sort of an easier way to sort of translate and talk about a limit is they want to know what value are we approaching as you look at the graph from both sides and you come in from the right and the left. We're talking about a y value. What value are we approaching? So here's what we're going to do. I'm going to do this first one with you, and then I'm going to pass this out, and you guys can do the rest on your own. It says, use a graphing calculator and the trace feature to help you answer A, B, and C, sketch a graph, and use algebra techniques to help you answer D. So here we go. Number one, we're all going to go to our y equals button, and we're all going to type in x squared minus 4. And what do you have to remember as you type that in? Parentheses, thank you, or it won't work. Hit zoom 6 so you can graph it. It says to sketch a little graph, so I'm going to go ahead and do that. And we might have to adjust that graph here in a bit. Can you guys even see that pen, or is that too light? You can see that. It's a little light. Let me go back and fix here in a minute. There we go. All right, so it kind of looks like that. Letter A. If x is approaching 2, you know what the word approaching means. It doesn't mean what is x at 2. That's not what it's asking. It says as it approaches 2, what is f of x or y approaching? Here we go. Push trace. And it probably is going to start you at 0, 2. Push the right arrow and watch those x's increase. It's getting closer to 2. I'm at 1.96. I'm almost at 2. And my y values are getting really close to 4. If I push the right arrow key one more time, it has now skipped 2, and we're at 2.1, and it skipped 4, 4.1. So it looks like it approaches what? 4. It looks like it does. Here's how you would write it. You would say the limit of f of x as x approaches 2 from the left, that's what that little minus is 4. You could also say that the limit as x approaches 2 from the right of f of x is also 4. Those numbers, in this case, match. They don't always match. In this case, they do match. They're both approaching 4. So they come in from the right and the left, and they get really close to 4. So the answer, this is kind of how we're going to write it sort of in calculus. But we can just say that the answer is 4. Letter B, at x equals 2, does the function have a defined value? It's a whole. How do you know that? Yeah, if you factor this thing, Carson thought real fast and said, oh, it's going to cancel out and you're going to get a whole. Here's how the other way you can find that is, because sometimes you're not going to be able to like look and know. So we hit second window. We're going to set up our table. Look, we're going to start at 0, and we're just going to delta change of 1. We're just going to change in increments of 1. Actually, no, let's put 0.1. And let's start at 2. Table start at 2, and we're going to go up in increments of 1/10. Go to second graph so that you can see the table. And you kind of push up and down as you're coming in from the left-hand side of the graph. It's getting close to 4, and then there's an error. As you're coming in from the right-hand side of the graph, you're approaching 4, and then there's an error. So according to this, right at 2, it's undefined. So we say, no, it doesn't have a defined value. Why or why not? Because it's undefined at 2. Or there's a hole there. Or point discontinuity, or whatever you want to say on that. So those 3 things we can do with our calculator. Just keep in mind when you're using your table function, because this is going to come up. It's not going to be quite so obvious as the number 4. It might be something weird, like, I don't know, 0.988 or 2.715 or something like that. It's going to be, like, there are going to be some weird numbers on here. You might have to go to your table, and you might have to say, start at 1.9, and you're going to go up in thousandths. You might have to do that and then check out your table and kind of see what happens. That may be something you need to do. The other thing you can do, go back to your graph, hit trace. If I want to know quickly, without looking at my table, kind of where is this graph at 2.000001, so I'm super duper duper close to 2. I can hit enter, and it will tell me it's at 4.000001. So that's another fun feature that you can use as well. Another way to get there is second, trace button, and you can hit 1 for value. Whoops. Sorry, I screwed up. My bad. Oh, man. There we go. And then you can type in a value like, I don't know, 1.9999. Did I just hit negative? Sorry. And then they'll give me 3.9999. You can do it that way as well. Letter D. Factor and reduce. We did. Carson kind of got us started. And what I'm left with is f at x equals x plus 2. That's what I'm left with. Do you remember how last week when we were trying to figure out the exact address, the ordered pair for the whole, I had you factor and reduce first, and then we took that number and we plugged it in? This is the same thing. So you have to solve for f at 2. Replace x with 2, and we get 4. So algebraically, we have proved that we are approaching 4. So graphically, it approaches 4, and algebraically, it approaches 4. Are there any questions with any of that? Yes, sir.
On those limits, if they're both approaching 4 from both directions, can you just write it as one limit without this?
Yes. You can write this as one limit. We can just say the limit as x approaches, whoops, that's an arrow, approaches 2 of f of x is 4. That's coming from both directions, Tristan. This one's coming from the left. This one's coming from the right, because these numbers may not always match. Great question. All right, so you guys have seen it. You're going to work through this lab kind of with your little partner, front and back tomorrow, and it's not that bad. Okay? If you've got questions, please come ask, because sort of all of your calculus for this semester is going to hinge on this limits business. You start a clean slate today. We talked about functions, we took a test, blah, blah, blah. You can start fresh today and really bust it and really, really do well this semester, okay? That trick's not going to come back to bite you too badly. Okay, let me hit stop on this. I don't know what that noise is, but we just stopped.